Hello friends, welcome to Mechanical Engineering online classes. Today's lecture will be delivered by Miss Shravani Sriramoju.
Let us see how flow shop scheduling is done for n jobs that will pass by two machines or that are processed on two machines. The assumptions in this are as follows. First is that there are only two machines that are involved, say machine A and machine B, and that each job is processed in the same order, because in flow shop scheduling all the jobs will have the same processing order. So let that order be that every job will first go to machine A and then it will go to machine B. So this order A and then B is for every job. The third assumption is that the setup times of A and B are independent of the sequence of the job, and that the storage space for all the jobs is available, and for small processing, for a short processing time, the cost of in-process inventory is negligible, or it is same for all the jobs and its negligible is small. This assumption we have already seen in the general assumptions of our sequencing. And fifth point is that the order of completion of jobs is not important. Means no job is having a special priority, that this job is required immediately or that job is not needed until the end. There's nothing like that. Every job can be chosen in an order such that the total elapsed time can be minimized. So there is no priority on a particular job. Job means the workpiece that is going to a machine, for example. And that the processing times are also known and they can be represented as a table. Say for example, on machine A, job 1 will take A1 time and job 1 will take B1 time on machine B. So for job 2, the processing times are say A2 and B2 respectively on A and B, and so on. So processing times are represented as a table. And the objective is find the optimum sequence of the jobs that will minimize the total elapsed time from the start of the first job on first machine to the completion of last job on the second machine. So if that total time is T, the minimizing this total elapsed time for every job to be completed on both the machines, that is the total elapsed time. So that should be minimized. That will be our objective. And S.M. Johnson and R. Bellman, a procedure to solve the problem of this kind, which is popularly known as Johnson's rule. So let us learn this, means what Johnson rule is and how to implement it with the help of an example. So for which let us first see a question. The question goes on this way. A machine operator has to perform two operations, namely turning operation and facing operation on a different number of different jobs. The time that is required to perform each operation in minutes for each job is known and is shown here in the table. So job 1 takes 3 minutes for turning, 8 minutes for facing. Job 2 takes 12 minutes for turning and 10 minutes for facing, and so on up to job 6. So we have to find the order in which the job should be processed in order to minimize the total elapsed time, such that total elapsed time means the first job going on to the first machine to the last job completing its job on the last machine. Also find the total processing time and idle times for both turning and facing operations. So because this is an example of n jobs processing on two machines, we shall apply the Johnson rule. And another point is that the processing order should be fixed. So nothing is mentioned like the facing should be done first and turning next or anything like that, but in the question it is mentioned that turning and facing. So first every job should go for the turning machine, and once the turning is done, then it must go for facing operation. So the order, the processing order is turning and then facing for all the jobs. So we will find the sequence of jobs, the order in which jobs should go to first machine only. The same order will go to the second machine, right? So finding the order in which every job should go to the first machine is the same order that they all go to the second machine. So according to Johnson's rule, the first step is to examine the minimum of AI and BI. Means suppose this is the A machine, turning machine. This is the B, facing machine. Alright. So we have to examine the columns. In the A column, the minimum is 2. In B column, the minimum is 1. So according to Johnson rule, here, in case a job, which is that job, the minimum in all these times is 1. This is the minimum of all the times. Then, because this minimum is coming on the second machine, it should go last on the first machine. If at all, for example, this is a order in which all the jobs should go to machine A. If at all the minimum, if at all this was not 1, if suppose this was 10, then the minimum will be this 2. So if because job 4 is having minimum time among the table, in the entire matrix the minimum is 2, say for example. Then job 4 should first go to machine A because this 2 is on machine A. So for A sequence, 4 will go first. Alright. So because fourth job is having minimum time on A, it will first go to A. In similar way, if we examine all these values, this entire table, then the minimum is this 1 and this 1 is on machine B for job 6. So because it is minimum on machine B, so this job is sent in the last to machine A. So that means that will go last to the machine B also. So what all jobs should first go to A and then B. This is for job orders going to machine A. So because 6 is, so it will first go to A, last go to B. After all this sequence is done on A, then the same sequence in the same order will go to machine B. So because 6th job is having minimum on B, 6th job will go last on A. So job number 6 comes here. It will go at last to machine A and therefore to machine B also. And once the 6th job is already placed, we have to now check with the rest of the matrix. 1 to 5 we have to see. What is the minimum in this 1 to 5? In these times the minimum is 2. The minimum is 2 for job 4. Now because this minimum is on A, job 4 is first sent to machine A. If this 2 was again falling under say column B, then this 4 will come here. Alright, so minimum on B will come from this end, minimum on A will come from this end. So because 4 is having minimum time on A, then 4 will first go to A. Now 4th job is also completed. We don't have to check with 4th job and 6th job. Now whatever is remaining, 3, 8, 12, 10, 5, 9, 9, 3. Whatever is minimum in these, the minimum is 3. This minimum is 3 for job 5 on machine B. So because it is minimum on machine B, we will write the 5 here. Now this 5th is also done. Now we have to check with the remaining ones. Now job 1, 2, 3 are left. So the minimum of 3, 8, 12, 10, 5 and 9 is 3. So because this minimum 3 is on column in the first machine, then job 1 will go to machine A first. Now job 1 is also scheduled. The remaining 5 minutes is the minimum, that is for job 3 on machine A. So 3 will come first to A. And whatever is left is here. Now this is the sequence or order of jobs that are going to machine A. So fourth job will first go to machine A, then B. A means here it is turning, then facing. So fourth job is first going to machine to turning machine, then it will go for facing. After fourth job, then job number 1 will go to turning. Then after 1, job 3 will go to turning. And after turning is over, it will go to facing. Alright, so this is the same order in which it goes to A or B. So after this is the same sequence. Now once the sequence is known to us, let us find the processing times and the total elapsed time. So for the obtained optimum sequence, let us find the processing time. So which job is going first? First job number 4 is going. It is going to the turning machine first. So let us note down the time in and its time out. So because it is the first job that is going on to the first machine, let us say that it is from 0th minute. So how many minutes is this job 4 taking on turning machine? It is taking 2 minutes. So time in is 0, time out will be 2 minutes. So in 2 minutes it is completing its job on turning machine. Then it must be going to the facing machine. Let us also take down its time in and time out. Now according to our assumptions of in sequencing, each machine can do only one operation at a time, and that after one operation it will go to the other machine. So if we are assuming that the facing is happening on a different machine, then after 2 minutes from the time datum of 0, it has taken 2 minutes for turning operation. So from the second minute it is taking how much time? Fourth job is taking 6 minutes on facing. So from 2 minutes how much it will take? It will take 8. So 8 minus 2 will be 6. So total 6 minutes. So at 0th time it has started, and in 8 minutes it has completed all its operations on any machine. After 4th job, first job is going on to turning machine. When is this turning machine becoming free? After 2 minutes. 4th job has taken 2 minutes on turning machine. So immediately after that 2 minutes, our turning machine is now idle. So our job 1 will start its work from the second minute itself. Alright, so from second minute. So job 1 needs 3 minutes on turning. So if it has started at 2 minutes, it will end up at 5 minutes. 5 minus 2 is 3, right? So once this is completed, now job 1 will have to go for facing. But facing machine is busy up to 8 minutes. So until job 4 is completed, job 1 cannot go on for facing. So after 8th minute only it will start. So it is staying idle from 5th minute to 8 minutes. So once at the 8th minute facing machine is idle or freed, then job 1 is taking up, and it has begun its operation on its operation has begun on facing machine at the time 8. Now how much time it needs on facing machine? It is 8. So from 8 it needs 8 minutes. So the total is 16. Alright, so in first 16 minutes our job 1 is also ready. Then after job 1 it is finished its turning in the 5th minute, right? So now job 3 will go. Job 3 will go to turning machine. How much time does it take? 5 minutes. When is our turning machine free? After 5 minutes. So after this fifth minute, from this 5, our turning machine is free. So job 3 is going at the 5th minute. It needs more 5 minutes. So the total is 10. Alright, so similarly after third job goes second job on turning machine. So when is turning machine free for second job? The 10th minute. How much does it need? It needs 12 minutes. So 10 plus 12 is 22. And similarly after second job, fifth job should go. Fifth job will take 9 minutes on turning machine. But when is turning machine free for the fifth job? After 22 minutes. So from 22 it will take 9 minutes, which is 31. And finally what is going? The sixth job is going on to turning machine. When is turning machine free for job 6? After 31 minutes. So from 31st minute it will take how many minutes on turning machine? 11 minutes. So 31 plus 11 is 42 minutes. So this is all the processing times in the same time horizon for all the jobs. Now third job is out on turning machine at 10th minute. But here if we see, it has to then go to facing machine, right? But till 16th minute facing machine is busy. So because only after 16 minutes it is getting freed, then our job number 3 will go to facing machine from 16th minute only. So job 3 is taking how many minutes on facing? 9 minutes. So 16 plus 9 is 25. Now job 2 is ready at 22 minutes only, but facing machine is free only after 25 minutes. So it will start working. So facing machine will take up job 2 only from the 25th minute. How much time, once it is on the facing machine, how much time job 2 takes for the facing to be done? 10 minutes. So it is 25 plus 10, that is 35. Alright. So again, after 35 minutes only, our job 5 can be taken up by the facing machine, because job 5 is already ready, it is idle until 35 minutes is rung. So at 35th minute, 5th job is taken up by the facing machine, and how much time will 5th job need on the facing machine? It takes 3 minutes. So 35 plus 3 is 38. Now here, after 38 minutes, facing machine has completed all operations on these 5 jobs. Now it is waiting for the 6th job to come. But the 6th job is busy in the 38th minute on turning operation, because from 31 minutes to 48 minutes it is on turning machine. So our facing machine is now waiting for the 6th job to be out from the turning machine. When will 6th job be out of the turning machine? In the 42nd minute. So at 42nd minute, 6th job is going on to facing machine. And how much time will it take on the facing machine? It takes only 1 minute. So that is 43. So what is the total time? Now the 6th job, the last job coming out of the last machine is this. The first job going onto the first machine is this. So 0 to 43 is the total time. So what is the total elapsed time? It is 43 minutes. So therefore the total elapsed time is 43 minutes. Now let us see if there are idle times for turning machines. So where is turning machine idle? From 0th minute only it has taken up the products, the jobs. 0 to 2 it is busy with 4 jobs. From 2 to 5 it is busy with first job. 5 to 10 it is again busy. From 10 to 22 it is busy. 22 to 31 it is busy. 31 to 42 it is busy. So from 0 to 42 it is non-stop busy. All that it is waiting is only for this job 6 to be completed. In this 43 minutes it has waited only 1 minute, because its job has ended in the 42nd minute, and all the jobs will be completing all the requirements by 43rd minute. So it is 43 minus 42, only 1 minute turning machine is idle. So therefore idle time for the turning machine is 43. This 43 minus this 42. We have to check like this. Alright. So it is 43 minus 42, which is 1 minute. Now let us see the idle time for facing. Now job 4 has started, is been taken onto turning machine at the 0th minute, and this job 4 is taken onto the facing, on for facing only from 2nd minute. So from this 0 to 2 facing machine is idle. So that idle time is 2 for the 4th job, plus it was busy till this 8th minute, and after 8th minute it has taken up first job. It worked on it for 16 minutes, and once 16 is, and after 16 minutes it has taken up third job. It has worked for 25 minutes, and after 25th minute it has again started working on the second job up to 35 minutes. After 35 minutes it has been taken up by the 5th job, and it's till 38 minutes. After, from this 2 minutes to 38 minutes it is busy. After this 38 minutes it waited for the 6th job, and 6th job has come in 42nd minute. So what is the waiting time? It is 42 minus 38. At the 42 minutes 6th job has come. Our facing machine is busy up to 38 minutes. So 42 minus 38. So this initial 2 plus this waiting time. This waiting time is 2 plus 4, which is 6 minutes. So idle time for the facing machine is 6 minutes. So this is how we have to find out the idle time for the second machine. So that means if the cycle is repeated, then the turning machine will be idle for 1 minute, as unless the last job of the previous cycle is completed, the new cycle cannot be started. Alright, so this is a solution to the given question. And sometimes it is also possible for us to have a multiple optimum sequence. For a multiple optimum sequence, we have to take down the different sequences and write down the table, time in, time out and idle times for the different sequences, different optimum sequences. But the total elapsed time will be the same, and even the idle times also will be the same. So in case I solve that problem, I'll put that link in the description of this video. You may check it.
Thanks for watching. If this video was of help to you, please like it and share it with your friends. And don't forget to subscribe to our channel.